All right, folks, what we want to do is we finally want to investigate non-spontaneous processes by looking at electrolytic cells. And we're going to explore some of these stoichiometric calculations that we can find out a lot of information about electrolytic processes. So the first thing we want to do is we want to actually go through and define a few things in terms of current and charge and just talk about some of the general things you're going to look for in problem solving. So what happens here is, electrolytic cell, you're actually causing a non-spontaneous reaction to occur. So in this case, you could turn rust back into metal, for example. But what we're doing is how fast it goes and the extent that it goes depends on how much current is flowing. So what we're going to see is that the charge Q is equal to the current times the time in seconds. And then that is equal to the moles of electrons times Faraday's constant. So this is a lot of information. There's a lot of relationships that we can explore. So I find the best thing to do with electrolysis is just to jump in and go ahead and try a few practice problems and talk about stoichiometric conversions and how to cancel things out. So here, let's go ahead and look at the electrodeposition of copper. So the sample is dissolved to produce copper 2+, which is electrolyzed. At the cathode, the reduction half reaction is copper 2+ plus 2 electrons yields copper. What mass of copper can be deposited in 1 hour by a current of 1.62 amps? All right, so the first thing that we want to do is we want to think about if you're usually either given a current or you're solving for the current most of the time. But I usually try to start or end with the current, and then I can find things from there. But instead of remembering all these equations so for instance, the charge is equal to the current times the time, you can really pay attention to your units and do some dimensional analysis. So since it's 1.62 amps, an amp, recall, is a coulomb per second. So we have 1.62 coulombs per second. All right, so if we are trying to go through and find the mass of copper, we're going to have to get our coulombs to cancel. So the thing that we can use to cancel out the coulombs would be Faraday's constant, which is 96,485 coulombs for every 1 mole of electron. Okay, so the coulombs cancel. Well, how many moles of electrons are being transferred here? Well, what we can see is there are 2 moles of electrons for every 1 mole of copper. Okay, so now our moles of electrons have canceled. We're in terms of moles of copper per second, but we're not interested in moles of copper. We want to know grams of copper. So we can convert our moles of copper into grams. So we use the molecular weight of copper, 63.55 grams of copper over 1 mole of copper. So our moles of copper cancel. So now we're in grams of copper, but it's grams per second. So we need to get our seconds to cancel. So it tells us in the problem that this is occurring for 1 hour. So let's convert our seconds to minutes. So 60 seconds for every 1 minute. Then there's 60 minutes in an hour. So seconds cancel. Minutes cancel, and we have 1 hour, so we can multiply through by our 1 hour. The hours cancel, and what we can do is we can go through and plug all this in our calculator. Keep in mind, anything in the numerator you're multiplying by, anything in the denominator you're dividing by, and we find out that we could deposit 1.92 grams of copper using a current of 1.62 amps for 1 hour. Okay, so that's how you can solve these problems. Let's try one more together. All right, so in this problem, it says if 12.3 grams of copper is deposited at the cathode of an electrolytic cell after 5.5 hours, what was the current used? So recall that current is measured in amps, which is in terms of coulombs per second. So we need to end up getting coulomb per second. So what I would do is I would start by thinking, okay, well, I know somehow with Faraday's constant I can convert my grams by getting it to moles and use Faraday's constant to get that to coulombs. And I need to keep time in the denominator. So I would start out like this. The first thing I'd do is I would convert the 12.3 grams of copper into moles. So I have 1 mole of copper in the numerator, the molecular mass in the denominator, 63.55 grams of copper. Okay, so grams of copper cancel. Now for every 1 mole of copper, we'll assume that it's going to copper 2+, and I would be more specific in a homework question, but since it's based off the previous question, we'll use 2 moles of electrons. And now we can go from moles of electrons to coulomb using Faraday's constant, so 96,500 coulombs for every 1 mole of electrons. So now we have coulombs, so now we need to get our hours to seconds. So we know that in every 1 hour there are 60 minutes. In every 1 minute there are 60 seconds. So hours cancel, minutes cancel. And our resulting units would be coulombs per second, which would tell us the current. So our current needs to be 1.89 amps. And that does it for electrolysis.